In the triangle ABC, so ABC, DE is parallel to BC. So DE is parallel to BC. Part 1. Prove that AD over AB is equal to AE over AC. So I'm going to start by labelling AD as TL, which represents top length, DB as BL, which represents bottom length, AE as top length, and EC as bottom length. So by the line parallel to the base of triangle theorem, this tells us that the top length divided by the bottom length will be equal to the top length divided by the bottom length. So the top length on the left hand side is AD. So we've got AD as our numerator in our first fraction. And the bottom length on the left hand side is DB. So we've got DB as the bottom of our first fraction, or our denominator. Then we have the top length on the right hand side is AE, and that's going to be divided by the bottom length on the right hand side, which is EC. So we have AD over DB equals AE over EC. So the first thing we're going to do is flip each of the fractions upside down. So AD swaps with DB, so we get DB over AD, and AE swaps with EC, so we get EC over AE. So now we have DB over AD equals EC over AE. Next we're going to add 1 to both sides. So we're going to plus 1 to the left of the equal sign and plus 1 to the right of the equal sign. But I'm actually going to rewrite it as 1 over 1 because I want it to be a fraction. So 1 can be rewritten as 1 over 1 on both sides. So now what I want to do is simplify the left hand side. So I want to do DB over AD plus 1 over 1. So my common denominator is going to be AD. AD divides into AD once, so we end up with DB multiplied by 1, which is just DB. And 1 divides into AD and leaves us with AD, and AD multiplied by 1 is AD. So DB over AD plus 1 over 1 gives us DB plus AD over AD. Then we do the same on the right hand side. So our denominators are AE and 1, so our common denominator is AE. AE into AE goes once, and 1 multiplied by EC is just EC. And then 1 into AE leaves us with AE, and AE multiplied by 1 gives us AE. So EC over AE plus 1 over 1 gives us EC plus AE over AE. So now we want to add DB plus AD. So this is DB, it's the bottom length, and this is AD, it's the top length. And the bottom length plus the top length will give us the overall length. OL stands for overall length. So DB plus AD gives us AB. So DB plus AD gives us AB. So the bottom length plus the top length gives us the overall length. So DB plus AD gives us AB. And it works the same on the other side. EC, which is the bottom length, plus AE, which is the top length, gives us the overall length, which is AC. So EC plus AE becomes AC. So now we have AB over AD equals AC over AE, and we're just going to flip them upside down. So AB becomes the denominator, AD becomes the numerator. We do the same on the right hand side, so we get AE over AC. And this is what we were asked to prove. We're asked to prove that AD over AB is equal to ACE over AC. So we've proved that. Part 2, prove that DB divided by AB, so DB, the bottom length, divided by AB, the overall length, is equal to EC divided by AC. So EC, the bottom length, divided by AC, the overall length. So we're going to use what we proved in part 1, And we proved that AD over AB is equal to AE over AC. So we're going to start by writing that down. AD over AB is equal to AE over AC. And we're going to subtract 1 from both sides. So we're going to have 1 minus AD over AB is equal to 1 minus AE over AC. And again, I'm going to change 1 into 1 over 1 so that I have fractions. So now I want to work out 1 over 1 minus AD over AB. So my common denominator with 1 and AB is going to be AB. So 1 into AB leaves me with AB, and AB multiplied by 1 is AB. And then AB into AB goes once, and 1 multiplied by AD is just AD. So 1 over 1 minus AD over AB gives me AB minus AD over AB. Then I'm going to do the same on the right hand side of the equal sign. So my denominators are 1 and AC, so my common denominator is AC. 1 into AC leaves me with AC, and AC multiplied by 1 is AC. Then AC into AC goes once, and 1 multiplied by AE leaves me with AE. So 1 over 1 minus AE over AC leaves me with AC minus AE over AC. So now I need to work out AB minus AD. So AB is the overall length on the left hand side, and AD is the top length on the left hand side. And the overall length minus the top length leaves us with the bottom length. So AB minus AD will leave us with DB. So AB minus AD leaves us with DB. So AB minus AD changes to DB. And it works the same on the right hand side. So AC minus AE. AC is the overall length. AE is the top length. And AC minus AE leaves us with EC. So AC minus AE leaves us with EC, which is the bottom length. So we end up with DB over AB is equal to EC over AC, and that's what we were asked to prove.